Nth roots and rational exponents. Let's look at example number 1. So how do we evaluate this example? A common misconception is that when you have a negative outside and a negative inside, you can distribute. And most students say, oh, a negative times a negative is a positive. You cannot do that as we evaluate this expression. So what we're going to do is we're going to identify the nth root, which is 3. Then we're going to go into column 3, and I'm going to find 125. And I can see that 5 times 5 times 5 3 times is 125. But I don't have a positive 125, it's negative. So I place a negative in front of all 3 values because these have to be the exact same value. If you've forgotten this rule from middle school, you can count the number of negatives in expression. In this case, we have 3 negatives. If that value, I've been counting the number of negatives, is odd, your final answer is negative. If this value of negatives would have been even, my final answer would have been positive. So I know that these multiply to give me a negative value, and 5 times 5 times 5 is 125. How does that help us? That means just this portion evaluated is negative 5. Then I have to bring down the negative sign out front. So it's like negative 1 times negative 5. Well, 1 times 5 is 5, and I have 2 negatives. 2 is even. My final answer is positive. Let's look right now at example number 2. Example number 2. So I'm going to go into column 3, and I'm going to identify where is 216. Does it exist in this column? So in column 3, 216 is right here. That means 6 times 6 times 6 3 times is 216. So 6 times 6 times 6 3 times is 216. So this portion is 6. Now I need to take negative 3 times 6. Well, 6 times 3 is 18. And we only have 1 negative. 1 is an odd number. Final answer is negative. Let's look at example number 3. Example number 3. Remember, I cannot distribute this negative sign through. I'm going to look into column number 5. I'm going to look at column number 5, and I'm going to find the 243. Column 5, here's 243. 3 times 3 times 3 times 3 times 3, 5 times is 243. But I want to make sure to have a negative 243. So I'm going to throw a negative sign in front of all 5 values. 3 times 3 times 3 times 3 times 3 is 243. And I have 5 negatives. 5 is an odd number, so this is negative. That proves to me that this portion is negative 3. Then I have the negative sign in front. This is really like a negative 1 times negative 3. Well, 1 times 3 is 3. 2 negatives, well, 2 is an even number. This final answer is positive. Let's look at example number 4. So I'm going to go into, I identify what is the nth root, and I go, okay, I got to go to column 4. I'm right there, and I find 16. So column 4, and I identify where the 16 is. What does this mean? It means 2 times 2 times 2 times 2 times 2, 4 times is 16. So 2 times 2 times 2 times 2, 4 times is 16. Yeah, that works. So I bring down the 2. That's what this evaluates to give me, and then the negative 4. 4 times 2 is 8. There's only 1 negative. 1 is odd. Final answer is negative 8. Let's get started with here. So this is a tricky one. So I'm going to go into column 4, and I'm going to identify is 81 there. Column 4, 81, great. What does this mean? I'm going to go off to the side. It means 3 times 3 times 3 times 3, 4 times is 81. So I'm going to put that down. 3, 3, 3, and 3. Okay, got it. But I want to end up with a negative 81. So I'm going to put a negative sign in front. They all have to be exactly the same. It can't be like just one of them is negative. They all have to be the same. Okay, so yes, I agree. 3 times 3 times 3 times 3 is 81. How many negatives do I have? 4, which is an even number. That means this answer has to be positive, and it's not negative. There's no way to obtain a negative value when you have an even number of negatives. That means this is no real solution. No real solution. Now, at this part, we are going to review how do we evaluate when we have a rational expression. Sorry, we have a rational exponent. Rational means fraction, so we have a fraction in the exponent position. So we're going to break this apart and try to simplify it first. The very first thing we do is we always evaluate the number on the bottom. So really, I'm evaluating 9 to the 1/2. I'm doing just this part first. How do I do that? So I go into column 2. If you put down this example, please draw an arrow to the denominator in the exponent position. We always take care of that number first, whether it's larger or smaller than the numerator. So I'm going to go into column number 2, because there's a 2. I locate the 9. Okay, I've done that. I go straight back to the left, and it's 3. So this means what times itself? 2 times gives me 9. That answers 3. This part is 3, so I'm going to write down 3. But I haven't used the numerator, and I haven't used the negative sign out front. What's 3 times 3 times 3? Well, 3 times. You could do it mentally, or you could come to your paper and go, okay, here's 3 to the first, 3 to the second, 3 to the third. So this part is 27, and now we apply that negative sign. If we evaluated this original expression, the correct solution is negative 27. Let's look at the next example. Again, we are evaluating rational exponents. Draw an arrow to the 3, please. Draw an arrow to the 3. I'm going to go in the third column, and I'm going to locate 343. Third column, 343 is right here. I go to the far left, and I think the answer is 7. So I believe 7 times 7 times 7 is, I need a negative 343, so I'm going to put negative signs there. There's an odd number of negatives, because there's 3 negatives, so that is true. Negative 7 times negative 7 times negative 7 is negative 343. This part is negative 7, but now I have to apply it to the fourth. I haven't used the numerator. That means I'm taking negative 7 times itself 4 times. So we can look back over here, find 7, here's 7 to the first, to the second, to the third, to the fourth. So 24 over 1. Now, how do I know if it's positive or negative 24 over 1? Well, there's 4 negatives. 4 is an even number. This final answer is positive. Let's look at example number 3. First, please draw an arrow to the 5. So I'm going to go back over here, and I'm going to locate 1024. 1024 is right here in the 5th column. Okay, 1024 is right here. I go all the way back over here, moving it, and I get an answer of 4. So what I'm saying is 4 times 4 times 4 times 4 times 4, 5 times is 1024, but I need a negative 1024. Remember, we cannot distribute this through to make a positive. Okay, so there's 5 negatives. Well, 5 is an odd number, so this is true. This part right here is negative 4. I still need to take it to the numerator, to the third, and there's a negative sign out front. I cannot distribute that negative sign through. Now I'm going to take negative 4 times negative 4 times negative 4 3 times. Well, let's just figure out what's 4 times 4 times 4. Here's 4 to the first, 4 to the second, 4 to the third. So this part right here is 64, but there's 3 negatives. 3 is an odd number, which makes this negative. And we haven't used this sign yet. So this is what I need to evaluate last. What is a negative times a negative 64? A positive 64. How do we know that? There's 2 negatives. 2 is an even number. Final answer is positive. As a reminder, when you have a negative at the same level as the fraction sign, we are going to cross out that negative and push it up to the top to make life easier. Cross it out, push it up. Cross it out, push it up. Everything else will be the same. We'll be applying some rules you learned freshman year and we reviewed earlier this semester. So I'm going to circle this part. I'm going to go to the third column and locate 729. What does that tell me? 9 times 9 times 9 is 729. 9 times 9 times 9 is 729. Okay, great. So I've done this part. That's 9. I still need to apply a negative 2 and then afterwards a negative sign out front. Freshman year, you learned, and we reviewed it this year, if you have a negative exponent, I do not care about a negative base. If you have a negative exponent, it says it's not happy. It goes down to the bottom, and now it's happy. What is 9 squared? It's not 18. 9 squared is 81. So this final answer is 1 over 81, and then, by the way, we have that negative sign still that's out front. Now, that negative sign right here, you can put it on the bottom, the top, or the middle. As long as you write it down one time, you're good to go. Does not matter where it goes, top, bottom, or middle. So I've already moved the negative sign that was with the rational exponent up top. I'm going to go to column 5 and locate 32. This tells me that 2 times 2 times 2 times 2 times 2 5 times is 32. So 2 times 2 times 2, 5 times. But I want a negative 32. Well, that works because there's 5 negatives. 5 is an odd number. So this portion right here is negative 2. Now I need to apply the negative 3 up top. Now this is really tricky for students. Is the negative 2 happy? No, but what makes it not happy? Is it the negative sign out front with the base or the top exponent? So a lot of students struggle with this. So it still remains negative 2, but now the negative 2 is down below. It comes down below and it's happy. So I'm going to write negative 2 3 times in the base because we're going to cube it. So negative 2 times negative 2 times negative 2. And if you're struggling, what is negative 2 times negative 2 times negative 2? We'll come over here to the paper. Here's 2 to the first, 2 to the second, 2 to the third. So 2 times 2 times 2 is 8. And now I have 3 negatives. So 3 is an odd number. That means this answer needs to be negative. Well, where do I place the negative sign? I don't care if it's down below, up top, or in the middle. That's totally up to you.